Hello everyone and welcome to our course on Python for Data Science. In this video we will continue our discussion on sequence data. Today we are going to look at some of the other operations that can be performed on a sequence data. So, let us get started with the slicing first. In Python, we can extract a subset or a portion of a sequence data type, such as strings, lists, tuples, or ranges, using a process called slicing. To perform slicing, we use the slice operator, which can be represented in two ways, using the colon operator, or the slice function. The colon operator is the most common way to perform slicing in Python. It allows you to specify the start, stop, and step values for the slice. The syntax is sequence start, stop, step. The start argument is optional. It can be any integer value representing the index from where the slicing should begin. If not provided, it defaults to 0, the beginning of the sequence. The stop argument is also optional. It is an integer value representing the index where the slicing should stop, but not included. If not provided, it defaults to the length of the sequence. The next, step argument is also optional. It is also an integer value representing the step size or the increment between each index for slicing. If not provided, it defaults to 1. In this example, we sliced the string learning starting from index 1, the second character, e, stopping at index 4, but not including it, and taking every other character, step size of 2. Next, coming to the slice function, it is also used to create a slice object and then index the sequence with that slice object. The syntax for slice function is sequence, slice, start, stop, step. The arguments start, stop, and step have the same meaning as in the colon operator. This example produces the same output as the previous one using the colon operator. Both methods achieve the same result, but using the colon operator is more concise and commonly used. The slice function is useful when you need to create a slice object and manipulate it before applying it to a sequence. In summary, you can use either the colon operator or the slice function inside square brackets to perform slicing on sequences. The colon operator is more commonly used due to its simplicity and readability. Next, we move on to slicing of list sequence using the colon operator. In Python, lists are also sequences like strings, and you can use slicing to extract a sub-list from a given list. The colon operator is used to perform slicing on lists, and it allows you to specify the start, stop, and step values for the slice. The syntax for slicing a list using the colon operator is list, start, stop, step. Again, the meaning of start, stop, and step parameters are same. For an example, we create and sample list with elements like 1, 2, sam, and 2. In the first example, we slice the list from the beginning, since we didn't specify a start index, up to index 3, but not including index 3. In the second example, we slice the list starting from index 2 until the end of the list. The result is the sublist, sam, 2. In the third example, we slice the list with a step value of 2, which means we take every other element. In the fourth example, for slicing with start, stop, and step values, we slice the list starting from index 2, inclusive, and up to index 4, exclusive, with a step size of 1. You can combine different values for start, stop, and step to extract the desired sublist from a given list. Slicing is a convenient way to manipulate lists in Python without modifying the original list. Note that you don't need to use the slice function explicitly when slicing lists, or any other sequence, in Python. The colon operator provides a more concise and readable way to perform slicing operations. Next, we will discuss about slicing on nonsequential data. So for example, dictionaries and sets are nonsequential data structures in Python, which means their elements are not ordered or indexed like lists or strings. Therefore, the slicing operation cannot be directly applied to these data structures. To be specific, dictionaries store key-value pairs, and the values are accessed using their corresponding keys, not their indexes. Since the elements in a dictionary are not ordered or indexed, attempting to slice a dictionary will result in a type error, unhashable type slice. Similarly, sets are unordered collections of unique elements. Like dictionaries, the elements in a set cannot be indexed, so attempting to slice a set will result in a type error. Set object is not subscriptable. Since slicing is an operation that relies on the sequential nature of the data structure and the availability of indexes. Since dictionaries and sets do not maintain an order or provide indices for their elements, the slicing operation is not applicable to them. Now we will move on to the slicing operations on range objects similar to strings or lists. We can also perform slicing operations on range objects in Python using same colon notation. A range object represents an immutable sequence of numbers, and it is often used in loops or when you need a sequence of numbers with a specific step size. Let us now explain about the slicing of range objects. So in Python, the range function is used to generate a sequence of numbers. The result of range function is an immutable range object, which represents a sequence of numbers. We can perform slicing operations on range objects using the colon notation, similar to how we slice strings and lists. To illustrate, we create following range object called range_sample. This range object represents the sequence of numbers 1, 4, 7, and 10. The syntax range 1, 11, 3 creates a range starting from 1 up to but not including 11, with a step size of 3. Example 1, slicing from the beginning to a specific index. In this example, we slice the range_sample object from the beginning up to index 3 and convert the result to a list using list function. The output is 1, 4, 7. In the example 2 for slicing with a negative index, in this we see that we can also use negative indices to slice a range object. Negative indices start from the end of the sequence, where -1 represents the last element, -2 represents the second to last element, and so on. Here, we slice the range_sample object from the beginning up to the second last element, exclusive, using the negative index -1. The result is 1, 4, and 7. Example 3 for the slicing with a step value. So in this example we will see that we can specify a step value in the slicing operation, to be performed on every nth element from the range object. In this case, we slice the range_sample object with a step size of 2, which means we take every second element and the result is 1 and 7. Note that when slicing range objects, we need to convert the result to a list or any another sequence type using list function or a similar function, as range objects themselves are not subscriptable, like you cannot directly index or slice a range object. Slicing range objects can be useful when you need to work with a specific subset of numbers within a range, or when you need to skip certain elements in the range based on a step size. It provides a convenient way to manipulate and extract specific portions of a sequence of numbers generated by the range function. Slicing is a powerful technique in Python that allows you to manipulate and extract specific portions of sequence data types without modifying the original sequence. It is commonly used in data analysis, text processing, and various other applications where you need to work with subsets of data. Now we will discuss about concatenation of different sequence data types in Python with examples. Concatenation is the operation of joining two or more sequences together to form a new sequence. In Python, you can perform concatenation using the plus operator. Let us first start with concatenating of strings. So the strings are one of the most common sequence data types, and you can concatenate them using the plus operator. In this example, we will concatenate the strings hello and world using the plus operator, and the result is stored in the variable result. And the resultant output is hello world. Next, we will see the example of concatenating lists. So you can also concatenate lists in Python using the plus operator. In this example, we are concatenating the lists 1 and 2 using the plus operator, and the result is a new list containing all the elements from both lists. Now we will see concatenating tuples. We know that tuples are immutable sequences, but you can still concatenate them using the plus operator. In this example, we concatenate the tuple 1 and tuple 2 using the plus operator, and the result is a new tuple containing all the elements from both tuples. Next, we will discuss about concatenating iterables in Python. You can concatenate any iterables, like lists, tuples, strings, or even custom iterables, using the iter_tools chain function from the iter_tools module. In this example, we concatenate a list 1, 2, 3, a tuple 4, 5, 6, and a string ABC using the iter_tools chain function. The result is a new list containing all the elements from the concatenated iterables. Next example is concatenating sequences with plus operator. So, you can also use the plus operator to concatenate sequences of the same type, such as two lists or two tuples. However, you cannot directly concatenate sequences of different types using the plus operator. In the last example, we are attempting to concatenate a string and a list using the plus operator will raise a type error because they are different types of sequences. Similarly, we can concatenate sequences with plus equals operator. You can also use the plus equals operator to concatenate sequences of the same type and assign the result to the same variable. In the first example, we concatenate the lists 1 and list 2 using the plus equals operator, and the result is assigned back to the variable list 1. Similarly, in the second example, we concatenate the strings hello and world using the plus equals operator, and the result is assigned back to the variable str1. Now we will see that example of concatenating sequences with join method for strings. You can also use the join method to concatenate a sequence of strings. In this example, we use the join method with the separator comma to concatenate the sequence of strings. The result is a new string, hello, world, Python. So, the concatenation is a fundamental operation that allows you to combine multiple sequences into a new sequence. In Python, you can concatenate different sequence data types like strings, lists, tuples, and arrays using various methods and operators. The choice of method depends on the specific data types involved and your requirements. Understanding concatenation is crucial when working with sequential data in Python, as it allows you to manipulate and combine data from different sources or formats. And in the last we will discuss about the multiplication of sequence data types in Python. Let us first discuss multiplication of strings. So when you multiply a string by an integer in Python, it creates a new string by repeating the original string that many times. For example, in this case, the string hello is repeated 3 times. In the case multiplication of lists by an integer produces a new list that contains multiple copies of the original list, repeated the specified number of times. For instance, here, the list 1, 2, 3 is repeated twice, creating a new list. Additionally, you can multiply individual elements of a list by accessing them through indexing and using the asterisk equals operator. In this example, the first element, at index 0, of the list is multiplied by 3. Regarding multiplication operator on sequence data, the key points to remember are that the multiplication operation repeats the sequence the given number of times. For strings and sequences containing strings, it repeats the string elements. For numeric sequences, it multiplies the numeric values by the given factor. You cannot directly multiply a range object, as ranges represent an immutable sequence of numbers. The multiplication operation is a handy tool when you need to repeat or duplicate sequences, or create new sequences based on existing ones. It provides a concise and efficient way to manipulate sequence data types in Python. With this we will conclude this lecture, and in the upcoming lectures, we will focus on sequence data methods, which will cover various operations and techniques that you can apply to sequential data types, such as strings, lists, tuples, and arrays. We will explore the different methods available for manipulating and working with these data structures effectively. The lectures will provide insights into how you can leverage the power of sequential data methods to perform various tasks and operations on your data. We will delve into the specific methods and their functionalities, enabling you to work more efficiently with sequential data in your Python programs. Get ready to learn about the wide range of possibilities that sequence data methods offer, empowering you to handle and process sequential data with ease. By the end of these lectures, you will have a solid understanding of how to utilize the methods to achieve your desired outcomes when dealing with sequential data types. We hope that you have found this course informative. Please hit the like button and subscribe to our channel for more informative Python for data science content. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through Python's data science course. Thank you for watching and see you again.